Here is Mr. Bobo the Robo. He is my trash compactor robot. He is driven by two DC motors, as you can see on the bottom there. Each DC motor controls two wheels on its respective side. Now, Mr. Bobo the Robo is much larger, heftier than the previous robots, so he required a much larger chassis and wheels to be spread out further. So instead of creating a longer gear train with smaller gears, I instead used larger gears. These larger gears then had to come with larger wheels because I couldn't have that big gear dragging along the ground. They are also geared down. That way I can have a much larger output speed for each wheel, and thus helping move this heavier robot. So the main feature of Mr. Bobo is, of course, his claw and his arm. Both of them are powered by a DC motor. DC motor for the claw, DC motor for the arm. You come back here, see I created this structure. Well, I created the base with some sheet metal, and I screwed to these two pillars, which are parallel to each other and house the input shaft and the output shaft of the arm. The input shaft has two small gears which are attached to the DC motor, and they are meshed to these two larger gears which are attached to Mr. Bobo's arms. I decided to gear it up to give the arm more torque, and so it could pick up those cans much easier. Over here, the claw and the arm are screwed together, and at the end of the claw, I rigged up my Vex line tracker. So, Mr. Bobo uses two sensors. He uses a Vex line tracker and a Vex rangefinder that's located down here. Both of them are analog sensors. The Vex line tracker shoots out an infrared beam, which detects the reflectivity of the object in front of it. That reflectivity then provides a value for the Vex line tracker, which then allows it to detect what color it is. The ultrasonic rangefinder, that uses a high frequency sound wave as a sonar. One side emits a sound wave, and the other detects the sound wave, and then checks the time delay between the two and calculates the distance of the object. So final features I want to point out are, of course, the Arduino Mega and the battery powering everything on Mr. Bobo. I also have my bin tray here with borders because the bin kept slipping off every time. But I have my Amazon box here, which acts as the trash bin. And that's about it. Some problems Mr. Bobo gave me. Well, first of all, his arm and claw fixture are very heavy, so whenever he went to raise it up and drop it back down, he'd drop it with such violence and force that he would slam the claw into the front bumper, getting it lodged and stuck and unable to move again. So, in order to counteract that, I made the descent as slow as possible. That way he gently dropped the claw down and not hurt himself. I also had problems with the Vex line tracker and rangefinder. The Vex line tracker was originally posted further in, about right there. But whenever the claw went to grab the can, it would actually push the can away, out of range of the Vex line tracker, making it unable to detect the color of the can. So I created this little extension out of metal, bumping it out, allowing it to reach the can. The rangefinder also got an extension downwards, because before it would just detect the claw right in front of it, making the robot unable to move, because I had it set to stop whenever there was an object right in front of it. I also had problems with slack for the wires to the Vex line tracker and the DC motor for the claw, because whenever the arm went up, it would just rip its wires out of the Arduino Mega. So I had to create or include extensions to those wires, allowing the arm to make its full range of motion. Here's a brief overview of my program. At the top we have our libraries, including the new ping library, which is used for the rangefinder. We define our motors. We declare and initialize our VEX line tracker. It's at analog pin 0. Declare and initialize our rangefinder pins. The input's at 2, output's at 3. Then we have the parameters for our rangefinder. We got input, output, and max range of 50 centimeters. We create an integer for our can distance there, and then we declare and initialize our activation function. Up next we have in our void setup section we have the motor inputs. So motor 1 is at pin 41, 2 is at 39, arm is at 37, and call is at 35. Then we have our functions. So forward, robot travels forward, both motors go in the forward direction. Turn left, robot turns left. Motor 1 goes in reverse, motor 2 goes forward. Turn right, robot turns right. Motor 1 goes forward, motor 2 goes in reverse. And then halt, robot stops, both motors are stopped. Then we have our spread, so that causes the claw motor to spin and open up the claw. Grab, the claw motor spins the opposite direction and closes the claw. Lift, the arm motor lifts the arm. Drop, the arm motor spins the opposite direction and lowers the arm. Then we have our main section, our void loop section. So we declare the line tracker values here. Then we declare the rangefinder values. Now we have our if-else statements. So if activation function is low, then you start the program. Then if the can is within distance, between 2 and 8 centimeters, the robot will stop. If color is white, it will print white detected. Then it will pick up the can, throw it in the bin, lower the arm, and turn left. If the color is black, print black detected, pick up the can, throw it in the bin, lower the arm, and turn right. Then if the color is red, it will print red detected. Again, pick up the can, throw it in the bin, load the arm, but this time spin in a circle. And then after all that, it will put the activation function to high. If there are no cans detected, the robot will simply drive forward. Then if the activation function is high, the robot will stop completely.